Hello everyone, thank you for making it this far with me. So today I'm going to tell you a bit more about in-depth subsystems, and I want to talk about different intakes that are possible for you. So an intake is a system that can pick something up from somewhere on the playing field of the competition. So a few things that you want to look for in your intake is versatility. For example, if you have something that's picking up a ball, you want it to be able to pick it up on a large range if you're just taking it off the field, rather than the ball has to be exactly here to actually grab it. So being able to grab it with a large range helps it be more versatile. You can also use materials for this. Having something that's slightly more grippy can help it be more versatile in grabbing things. Another thing, the opposite side of this coin, is maybe you want it to be more precise. So it could be that you want something to go to an exact location. So in this case, you would want to have really refined angles and amount of power going to your motors for getting something to go exactly where you want it to be. For versatility, you often see basically a rod with some silicone wheels on it, which spin and pick something up. Because of the nature of the first games, you won't generally see an extremely precise subsystem because the field is unpredictable. So you want your subsystem to function with any given variable of where is the item. So when we're talking about precision in subsystems for intakes, we're mostly looking at how far apart or high the, say for this example, the rods are from one another, or maybe what angle it intakes them at. Those are two examples of what precision might look like in the setting of the intakes. So when you're building your intakes, there are several ways to make them more efficient as well. And one of these is troubleshooting. Troubleshooting is a very important part of build. So you'll often find that you build something and it will work in theory, but once you hit the go button, you see that, oh, it doesn't quite pick it up right, or it doesn't shoot high enough. There's different ways to do troubleshooting. You can maybe take a little video of the subsystem doing the task, and it can be also useful to put little markers. Maybe put a piece of tape on a part of the subsystem that you think might not be moving in the right way, just to see where it goes more easily in the little video you take. You can do this in slow motion maybe too, just to see it working slowly, or just looking in closely at each little part of the subsystem. So there's many ways to troubleshoot, but it is a very important part of building and making a good working subsystem. So I want to give you a few examples of intakes that are very commonly seen in the first competitions. So one of the ones I already briefly touched on, the spinning silicone wheels. So most competitions have something you have to pick up. We've seen wiffle balls or milk crates, rubber balls. So there's a bunch of different materials and shapes and sizes that they use, but these silicone spinning wheels, as I said before, they're a very versatile thing. So all you need to do, it's very grippy with the plastic that's on them, so you just need to approach the object, and as it's spinning, it'll grab onto it and pull it into the subsystem. So it's a very reliable subsystem, and it's very cost efficient too, because all the materials that you use for it are relatively cheap. But it's also important to test it because, as I said, shapes and sizes and materials will change the way that the subsystem works. I'll attach a video of it working in the bottom here. Another commonly seen subsystem is the claws. A claw has to have at least 2 fingers. Sometimes it has more. And claws are really good for something that demands a precise movement. So if you want to pick something up, like we've had pool noodles, let's say. You want to pick up a pool noodle, you want to be able to approach it and grab it, and then move it somewhere else. But you want to be able to grab it precisely and move it to a very specific location. So the claws are good at holding something captive, and it can be more complex to build than the wheel technique, but it does have its own upsides, as I said. When you're building them, it's good to have different ranges of motion, so different axes. And one way to think about this claw and arm kind of system is like your own hand and arm. So your fingers would be the gripping parts, and then you often have a wrist that can move up and down, and an elbow that can give it a longer range of where it goes. And some of them even spin a bit like this. So when you're building your claw design, you can even think of it like your own arm and use your arm as a demonstration just to figure out in your brain how you want it to look. So these are some of the primary intakes that you see. There are other ones. I encourage you to explore and look into different ones, but I'll attach some videos of all these 3 working at the bottom of the video.